Okay, all cells need chemical energy. All cells need what? Chemical energy. What do they use the chemical energy for? They use it to what? To get for all the metabolic activities.
Yeah.
The chemical energy used for all cell processes is carried by ATP. ATP carries the what? Carries the energy on the surface of the what? Of this on the surface of the ATP molecule. We've got ATP is called adenosine triphosphate. Adenosine what? Triphosphate. It's got 3 phosphate molecules. So molecules in food store chemical energy in the bonds. So this is starch molecule. So the molecules are stored in the what? In the bonds between the what? Between the starch molecule. You know what I mean?
Yeah.
The bonds between them. All these bonds is where they store the energy. ATP transfer energy from the breakdown of food molecules to cell functions. What is the meaning of this? When energy has been released, when a phosphate group is being removed, you know, ATP is a combination of what? Of 1, 2, 3 with an adenosine molecule, right?
Yeah.
So when you break off one, then energy is being released. So it becomes what? It becomes ADP, which is adenosine diphosphate. So when it releases energy, it becomes ADP. And when it wants to have energy again, it's going to take one phosphate molecule more, and it becomes ATP again. Whenever it's ATP, it has energy. But whenever it's ADP, it's already given off the energy it has. Is that understood? ADP is changed into ATP when phosphate group is added. So this is what we say. So it started with the addition of energy from breakdown of molecules is this. So it's going to add one ATP, one phosphate to the ADP to form an ATP. So you're going to have adenosine, then 3 phosphate molecule. So 1 phosphate molecule will be removed when energy is being released for cell functions or cell activities. Then what would you have? You're going to have adenosine diphosphate after the release of the energy. So organisms break down carbon-based molecules to produce ATP. What do they mean? Carbohydrates are molecules most commonly broken down to make ATP. Why? Because not stored in large amounts. They they have up to 36 ATP from 1 glucose molecule.
What does that mean?
Yeah, and in 1 glucose molecule, one glucose molecule would have 36 ATP. So 1 glucose molecule will be equal to what? 36 ATP molecules. So the meaning is it has let's say for example you eat a food that has 1 molecule of glucose in it, so that means you've got 36 ATP molecules in your body. So this is adenosine and this is phosphate. So they're just trying to tell you what makes all the triphosphate and the diphosphate, but it's not very difficult for you to understand. Now fats store more energy. You know why?
Why?
Because they have the particles are tightly packed together than the glucose particles. But the reason we don't actually depend on fat for source of energy is because it takes you a longer time to break down the fat to release energy from it than glucose. So if your body needs energy, it's going to take you longer time before the fat can break down to release energy than carbohydrate. So the meaning is you might have even died long time ago before the energy is being released from fat. But glucose can be released immediately, even from the mouth. So 80% of energy in your body is made up of fat, and about 146 ATP from triglyceride. That's the reason why you see people who are very chubby. You know what?
Osama, for example.
If they fight, Osama is gone. Osama is gone?
What?
Is he in school?
Yeah, he's in school.
Which Osama are you talking about?
My brother.
Oh yeah. I talked to Osama in your class. So if it's very chubby guys, they go into boxing, they easily win because they have more energy stored in the body because of the fat. But the skinny guys are just skillful. They might be skillful, might dodge, but if it's about physical energy, the ones who are chubby, they have more energy than the guys who are muscular. So yeah, this is the reason why you don't look down on chubby guys. They don't think they don't have energy. They have a lot of stored energy in the body. So about 146 ATP is found in 1 triglyceride. You know what I mean by triglyceride? Glycerol, 3 glycerol, which I mentioned to you last when we talked about that in grade 9. Proteins are least likely to be broken down to form ATP. Why? Because they don't have much energy in them. Amino acid not usually needed for energy. They're only needed for what? For the building of the body, to form new cells in the body. So that's what we use the amino acid for. So about the same amount of energy as carbohydrate. Yani protein have almost the same energy as carbohydrate. The meaning is one molecule of protein is going to produce how many ATP? 36. That's very good of you. So carbohydrate, you're going to have 4 calories per milligram of food you eat. If you eat for 1 milligram of carbohydrate, you're going to have 4 calories. But if you eat 1 milligram of lipid, you're going to have 9 calories. And if you eat the same 1 milligram of protein, you're gonna have the same 4 calories in it. So a few type of organisms do not need sunlight and photosynthesis as a source of energy. We have some organisms that don't actually need what they don't need to photosynthesize to get energy. Some organisms live in places that can never get sunlight. Like for example, the ones that live in deep down the ocean floor. They can never have access to oxygen, never. So they use a process of chemosynthesis. What is chemosynthesis? Chemosynthesis is a process of using chemical as a source of energy to make food. Like we said, photosynthesis, they use light as a source of energy. Chemosynthesis, they use chemicals as a source of energy to make food. So it says chemosynthesis is chemical energy is being used to build carbon-based molecules. It's similar to photosynthesis. They use chemical energy instead of light energy, and this is what we're referring to. In this place, you can never have access to sun forever. We have bacteria living in this place. And the way they make their food is they're going to use chemosynthesis to make their food. So this is all we have for that chapter. So